71, sure. Okay, let's take a look at number 71. This is on page 45. Page 45, number 71. Okay, so this involves everything. This is like gross. All right, so we have the top, which is 7.3 times 10 to the 2 plus 9.9 times 10 to the 3. All right, and I say those must first be in the same power of 10. So I'm going to make this 0.73 times 10 to the 3. That got bigger, that got smaller, plus 9.9 times 10 to the 3. And that means I have 0.73 plus 9.9 times 10 to the 3. And I also need a calculator. .73 plus 9.9 is 10.63 times 10 to the 3. Now, that has an uncertain digit in the hundredths and an uncertain digit in the tenths. Okay, so I'm just going to keep track of that. Now, the bottom, we have 8.73 times 10 to the minus 5. And we have minus 1.22 times 10 to the minus 4. Minus 1.22 times 10 to the minus 4. All right, so I'm going to change this to times 10 to the minus 4. You could, of course, go the other way if you prefer. Then that becomes 0.873 minus 1.22 times 10 to the minus 4. And that gives us 0.873 minus 1.22. Oh, that's going to give us a negative number times 10 to the negative 4. Have I done something wrong? Or has it, anyway, it's okay. We're pretending that I never do anything wrong. If I've done something wrong, it's okay. 873 minus 1.22 is negative 0.347 times 10 to the negative 4. Uncertainty is in the third decimal place and in the third decimal place. So what that means is now I'm going to take the top and divide by the bottom. And it does not have to be in scientific notation in order for me to do that, because I can just worry about putting my final answer in scientific notation. If I were just doing the top, I would have to change it into scientific notation and be done there. Yes?
Isn't the answer for the 0.873? It's in the hundredths.
0.873?
That's in the hundredths.
Tenths, hundredths, thousandths.
Oh, thousandths.
Yeah, thousandths position. Yeah.
The other one is the.
Oh, yeah. There we are. Yes, that's in the hundredths. Yes, 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 yes. Okay, so here we are. Good. Glad you caught that because that was important. Okay, so the top, we have 10.63. And my first uncertain digit is there, times 10 to the 3 over negative 0.347 times 10 to the negative 4. And when we throw that in the calculator, 10.63 E3 divided by negative 0.347 E negative 4 is, oh, Good God. Okay, it's like a huge number. So it is 3.0634 times 10 to the 368. Now, how many sig figs do we need? We look here and we say, I've got 3 sig figs here because the 6 is my uncertain digit. We have 2 sig figs here because the 4 is the uncertain digit. I forgot that this should be a negative. Okay. And so 2 sig figs, 3 sig figs, our final answer should go to 2 sig figs. Look to the right, negative 3.1 times 10 to the 8. Yes? We ready to write our quiz now? That's as bad as it gets, right? Most of the rest of them are not like that. Quickly tell your partner what is the rule for adding and subtracting and what is the rule for multiplying and dividing. While you do that, I'm going to go grab your quizzes from the photocopy. Everyone has a calculator? Yay! Who have I missed?
What it is element for yourself.
Thank you. Okay, folks, we are on page 51, 5-1. If you have not yet finished the quiz, that's okay, keep working. I'm recording this so you won't miss it. You can just watch the video, okay? And on page 51, I'm just going to point out a couple of things to you. If you're like, I would like Tyler to teach me how to do this because I did not understand it when Ms. Spence did it, you can watch that video. If you are like, how do I do this? There is a step-by-step, step 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You can go through those 13 steps. But I'm just going to show you the basic breakdown of how it works. Okay? How many seconds in one day? First thing you need to do is you need to identify your unknown, your initial quantity, and your conversion factors. Okay? Now, we have how many, that's a question word, and that's attached to seconds. So seconds is our unknown. We don't know how many seconds. Our initial quantity will be given to us in the question, and there's only one thing given in this question. We're given 1 day. Okay, so we're given 1 day. And our conversion factors, well, does anybody here know how many seconds there are in 1 day? That's in 1 hour. So you could do the math, but probably not. So what we're going to do is we're going to say we need to make a series of conversions. So let's draw ourselves a little map. What are we starting with? We're starting with our initial quantities. So we start with 1 day. And eventually we want to find the number of seconds. What could we change days into that would get us closer to seconds? We could change that into hours. And we could take our hours and go to minutes. And then we could take our minutes and go to seconds. The reason it is nice to write out a map is that you can then tell by how many arrows you have, how many conversion factors you will need. You will need 3 conversion factors. Okay? It's up to you whether you write them all down before you get going on the question or not. I'm not going to, just because I feel like most of you don't want to do that. Okay? So let's remind ourselves, we solve these problems by writing down our unknown equals our initial times conversion factor. But in this case, it's not just conversion factor, it's conversion factor number 1, conversion factor number 2, and conversion factor number 3. So we're going to have 1, 2, 3. Yes? Our unknown is the number of seconds. So I'm going to say, I don't know how many seconds I have, but I'm going to find it. Our initial quantity is 1 day. Okay, so we're going to fill that in here, 1 day. And then, I know this will seem crazy to you, but what I'm going to do is I know I have 3 conversion factors. A conversion factor is written like this, times line. So I am literally going to write out times line, times line, times line. Yeah? 3 times, 1, 2, 3. I'm not going to put anything in there. I'm just going to put my lines in. Okay? And now I say in step number 1, I want to go from days to hours. So my conversion factor needs to have days. Now, where am I going to put days? On the bottom so that it cancels out. Okay? And hours are going to go on the top. I'm not even going to bother filling in the numbers yet. I'm just going to do my conversion factors. Okay? My next conversion factor, I want to go from hours to minutes. So we need to cancel out the hours. Hours is on the top, so hours needs to go on the bottom. And I need to put minutes on the top because that's what I'm trying to find. So whatever you're starting with goes on the bottom, and whatever you're trying to find goes on the top. And now we're going from minutes to seconds, so we want to cancel the minutes, so we put it on the bottom. And we need to find seconds on the top. And now what you can do is you can go through and say, do I know the relationship between, say, hours and days? Yes, I do. How many hours are there in a day? 24 hours in 1 day. I also know that there are 60 minutes in 1 hour. Do you see how I left space in front of the unit so I can fill in my numbers? Okay. And I know that I also have 60 seconds per 1 minute. And now I can go through and I can say, I've got 1 day times 24 hours per day times 60 minutes per second times 60 minutes per hour and 60 seconds per minute. And that gives me 86,400. Now, we're not going to worry about sig figs for this one because probably I was wondering about an exact day. I'm like, if I give you an exact day, how many seconds are in it, right? If I give you an hour, how many seconds are in it? If I didn't give you a day, how many seconds are in that? So this would have infinite sig figs, just like that has infinite. 1 day has infinite sig figs, okay? Let's try a nasty example. Now, do you remember how I said I use this in real life? In real life, way back when, I used to coach the debate team.
Wow.
Way back when the school first opened. And I needed to drive some debaters to a tournament in Penticton. And this is on the next page. This is on page 52. No, not 52. It's probably on page 53. Let's see. Yep, it's on page 53. Yep. I needed to figure out what the cost of fuel was for that trip because I needed to get that cost out to in the cost of the field trip. So I looked up the distance to Penticton and found that we had a driving distance of 403 kilometers. So I'm going to you see how there's a lot of blah, blah, blah in this question? So many words. So what you're going to do when you see a question like this is you're going to be like, here is a number, and I'm going to say I have 403 kilometers, and that is my distance, okay, from Vancouver to Penticton. I looked up the highway mileage for my 2002 Honda Odyssey. Am I going to use that number 2002? Is that part of my calculation? No, that's just the year of the car. That's useless. And found that it was 25 miles per gallon. Here's another number. How would I write 25 miles per gallon? I can shorten miles to MI. That is the abbreviation for miles. What does per mean?
Every 1 gallon.
Per means divided by. Yes. So per means divided by. So I'm going to divide 25 miles per 1 gallon. I buy my gas in liters, so I have to convert gallons to liters, and we are told that 1 liter is equal to 0.26 gallons. And finally, I know my distance in kilometers, not miles, so I need the fact that 1 kilometer is 0.62137 miles. And the price of gas back in the day was $1.30 per liter. Whoa. Right? Okay, so the price of gas is $1.30. And remember, what does per mean? Per means divided by, and because we're doing things as conversion factors, don't do the slash thing. Don't be like $1.35 or $1.30 per liter. You want to write it as $1.30 per liter so that you know there is a top and a bottom, okay? So now we have a whole bunch of numbers. What am I looking for? What is the question asking? How much will it cost? Yes? So that is my unknown. My unknown is the cost in dollars. Yes? So what I want to do is I want to start with my initial quantity, and I want to do several conversions, and I want to get to my unknown. Which of these numbers should be my starting number? The 403 kilometers, okay? If you're like, how do I know that? Well, for one thing, it doesn't look like a conversion factor, does it? Conversion factor is always one thing over another thing, and that one does not look like that. So that means that is your initial quantity. Also, you can say, how much does it cost to make the trip to Penticton? Which of these pieces of information is about the trip to Penticton? The 403 kilometers. Yeah? And remember, in your question, the unknown and the initial will be connected. How much does it cost to get from Vancouver to Penticton? Yeah? So we are starting with 403 kilometers. What can we convert kilometers into? We can convert it into miles. So we're going to go to miles. What can we convert miles into? We can convert miles into gallons because we have a conversion factor for that. What can we convert gallons into? Gallons can go into liters. And then I can convert liters into, whoops, that was supposed to be a highlighter. I can convert liters into dollars, yes. Okay, so we can go from liters to dollars. Okay, how many conversions will we be doing? Four, yes? So my unknown is equal to my initial times 1, 2, 3, 4 conversion factors. Is this a required step to do in the problem? No, I'm just showing it to you to kind of like give you a structure to work with. Is the map a required step in the problem? I would say at this point, probably. However, if you have already done this in physics and you're pretty good at it and you find that you are easily showing all the work correctly and not getting messed up by it, you can leave out the map. But I would say if this is your first dipping your toe into the waters of unit conversion, I would do the map to start with until you feel really good about it, okay? So map is optional. I wouldn't bother with this unknown equals CF I times CF at all, okay? But what I would do is I would say my unknown is the number of dollars. So I don't know how many dollars. My initial quantity, we decided was 403 kilometers. And we need to do 4 conversions. What should I write 4 times? I'm going to write something 4 times because I have 1, 2, 3, 4 conversion factors. Times line, times line, times line, times line. Okay? You can do it without doing it this way, but again, if you don't have a lot of experience doing it, I would recommend this to start with. And even without knowing what I'm doing, I can look and I can say, I start with kilometers, therefore kilometers has to go on the bottom. I'm converting from kilometers to miles, so that means miles has to go on the top. Who goes on the bottom next? Miles go on the bottom next. And who goes on the top next? That is our gallons, okay? Because we're going from miles to gallons. Who goes on the bottom next? Gallons. Whoever was on the top here goes on the bottom here. And gallons are going to become liters, so liters go on the top. Gallons cancel out. And finally, we want liters to dollars, so liters cancel out. And dollars go at the beginning of that, so I'll put them at the beginning. Okay? And then you just go back into your problem and look for your numbers. Miles and kilometers. Oh, miles is long. It's 0.62137 miles per 1 kilometer. 0.26 gallons per, oh no, I want gallons per mile, not gallons per liter. So 25 miles per 1 gallon. 25 miles per 1 gallon. Do you see how I had to flip that one over? Right? And now I want gallons and liters, so that's 0.26 gallons per 1 liter. 0.26 gallons per 1 liter. And our final, $1.30 per liter. Yes.
Small error in the that, you go like 54.
Uh-huh.
0.25 gallons.
Oh.
Yeah, because it should be $50. And it's,
Oh, okay. For number 50, page 54.
yeah.
Error. 0.25. Yeah, that's a typo for sure. Thank you. All right. So let's do this calculation. 403 times 0.62137 divided by 25 divided by 0.26 times 1.3 equals 50.0824. Now, sig figs here. How many sig figs should we use? Well, we have 3 sig figs here. Yeah. We have 5 sig figs here. Is this 2 or is it infinite?
Oh, here we go.
Is it? Is it? If I say my car uses 1 gallon for every 25 miles, are those exact numbers? They're measurements. Somebody had to measure that about your car. They had to say it goes 25 miles on 1 gallon. So that's 2 sig figs. 0.26 gallons per liter, that is an imperial metric. So that's 2 sig figs. And here we have 3 sig figs. So our answer will be to 3 sig figs. So that would then become $50 and 10 cents. Huh? Why 3? Oh, 2. 2. 2. What is wrong with me? So it would then become $50. But we have to go to Penticton and back again. So it would become?
Only one sick thing. Oh, that's cool. Yay.
There we go. Okay, so that's now $100. And quite frankly, I'd be like, that's a nice round number. Let's just divide that by the number of students and off we go. Yeah? Yeah. So, again, this is not really a question that lends itself really well to significant figures, right? Because, you know, how accurate is that driving distance really? I don't know. Depends where you start from, all that kind of stuff. So I am going to get you for homework to do questions 1, 2, and 3. Okay, 1, 2, and 3. 2.3b, numbers 1 through 3, pages 54 to 55. If you want to do all of them, you can do all of them, but that gives you a start. If you are doing these questions, if you're at home and you're like, I cannot do question 1, or I cannot do question 2, if you want to do well in this course, what should you do? Ask questions, come to Flex. Okay? Long Flex tomorrow, so you can even just show up at your regular time and probably get some help, right? Cool beans. Thank you guys very much. Thank you for your hard work.
It reminds me of those, like, you know, San Marino characters. Yeah.